Hi, and welcome to the Unreal Engine News and Community Spotlight. UE4 gives teams the power to drive real-time animations and rapidly reduce their iteration times. You may recently seen this purple hairy monster on your TV and Monster.com's commercial Opportunity Roars. The spot, created by the talented team at the Mill, garnered numerous accolades, including a Cannes Lion Award for visual effects. But they weren't done yet. Monster.com wanted more than 24 15-second animated spots featuring the purple monster in just 3 weeks. Traditional methods of animation weren't an option with a short time frame, so the Mill came up with a clever solution. They would use a leap motion system to control the monster with finger motions, a kind of virtual puppeteering. The motions would drive the rig and generate real-time, finished output of the monster, purple fur and all, with Unreal Engine. Learn more about how the Mill leveraged Unreal Engine to drive their digital puppet for Monster.com in the behind-the-scenes video shared below. Bursting onto the scene in early access in April of 2017, Earthfall hopes to recreate and innovate on the magic Valve delivered with Left 4 Dead to the 4-player co-op shooter genre way back in 2008. Taking place in the not-too-distant future of 2031, players will be tasked with defending the lush environments of the Pacific Northwest against a violent alien invasion. Using the power of UE4's development suite, Holospark has created enemies that smartly adapt to not only each other, but the team dynamic as a whole, creating an experience like no other. Now, coming out of early access and launching on PC, PlayStation 4, and Xbox One, Earthfall is poised to fill that void created by Left 4 Dead's long absence from the gaming scene. We recently took some time to chat with Holospark CEO Russell Williams, as the growing developer filled us in on their thoughts about working with UE4 and protecting the human race from an alien devastation. Dive into the full interview in the link below to learn what Williams had to say. Each summer, SIGGRAPH brings together the heavy hitters of the tech industry to showcase the latest cutting-edge innovation in CG, interactive visual design, VR, AR, games, animation, and more. This year's Conference Expo runs from August 14th to August 16th at the Vancouver Convention Center. The Unreal Enterprise team will be set up at the show with lots of activities, presentations, and interactive demos. They'll host tech talks on real-time ray tracing, creating the Fortnite trailer using real-time production workflows, live performance capture and motion capture, virtual production-specific features in Unreal Engine 420, and others. Some special guests, the Mill, Third Floor, Technicolor, just to name a few, will join in to discuss their experiences with Unreal Engine. The team will also be hosting a mixer that week for UE developers. For full details, check out the link in the description and make sure to stop by and visit if you're at the show. Snail Games released the PixARK Dev Kit this week, giving creators wide access to PixARK's library of assets so they can build their own custom content for the game. With full Steam Workshop integration, the PixARK Dev Kit has everything needed to build and distribute experiences for all kinds for the PixARK community, along with a few surprises for ARK enthusiasts. Grab the PixARK Dev Kit from the Epic Games launcher to start creating new content of all sorts for the game. More info on our blog and the official PixARK wiki. Yesterday, we released Unreal Engine 420. With 420 comes many features we first showcased at GDC. You can take your visual effects to the next level with Niagara's particle editor, use the new Digital Humans technology powering the Meet Mic and Siren demos to raise the bar on realism, or achieve cinema quality camera effects in real time with the new cinematic depth of field. Epic has rallied around the mobile release of Fortnite to optimize Unreal Engine for mobile game development, with tons of performance improvement, and Proxy LOD is now production ready to further reduce the complexity of the geometry that needs to be rendered at any time. In addition to all these updates from Epic, this release includes 165 improvements submitted by the incredible community of Unreal Engine devs on GitHub. Thanks to all of our community devs that provided feedback on our previews and helped our team create this fantastic release. The Unreal Studio 420 beta is now also available. This new version, the result of months of feedback from our beta users, is chock full of great new features to make export, import, and editing in Unreal Engine easier and faster than ever. Unreal Studio 420 builds on the original suite of tools to bring you non-destructive re-import, metadata exposure, datasmith for SketchUp, mesh editing in Unreal Engine, plus a slew of additional improvements like CAD 2-pass import, per object tessellation, MDL support, extensible Python script for LODs, and more. Go download both today and check out the latest features. Onto our weekly karma. These folks are helping their fellow devs and just rocking the world. So, answering questions on AnswerHub. We thank you so much. Huge shout out to Shadow River, Hero Bank, 110, Mighty Enigma, Hustlin', Nebula Games Inc., Brian Johnstone, Dijo, Injab G, T. Sumisaki, and Pure Bob. You guys, rock my socks. Under our first community spotlight, this project is called Hearts of Violet. So it's an independent story-driven episodic game inspired by unique ideas of the far future, and yet trying to preserve the human condition as the center of narrative. In the game, you'll explore and discover the secrets of a fallen utopia. You'll survive amid rage, chaos, and suffering. And the city of Cividit Day is dying, but humanity doesn't have to. So they're working hard. Euthalia Game Studios is working hard to create a unique experience for ones who love strong narratives and immersive, rewarding exploration games. Our second spotlight is a project called Galaxia. So DexEffects is a new developer to Unreal Engine and has created a real-time procedural universe engine. So this amazing project allows you to explore the vastness of space and glean amazing celestial objects. They've done a really wonderful job of just capturing the spirit of exploration, and you should give it a shot. Our third spotlight is called Trail of Ayash. It's an exciting open-world game focused on the Native American people, their struggles, and their stories in the pre-Columbian era. The world is a unique version of America dominated by the myths and legends of its inhabitants, and the various tribes in the game. You'll interact with various tribes and engage in diplomacy, war, and expansion. Game looks great, and I love the tribute to Native American culture. And that's it for our news and community spotlight. Hi, and welcome to our Unreal Engine live stream. I'm your host, Amanda Bott. With me, I have Dave and Ryan from our incredible networking team, so thank you so much for joining us. And Tim, also community.
Hi. Hey, everybody.
So again, thank you. We're really excited. I know a lot of the folks have had questions around networking, and there's a lot of exciting changes here in 420 coming up. So what you want to give a brief overview of what you're going to dive into?
Yeah, I'm going to talk about Replication Graph first. That's a new system in 420 and is one of the major systems we did for Fortnite Battle Royale server optimizations. And then Ryan's going to talk about some more general networking stuff.
Yeah, I figured I'd talk about some more general kind of optimization techniques. The stuff isn't necessarily new in 420. You know, it's been around a while, but I figured it'd be good to, show it off, give you guys a refresher, or let you know about it if you didn't know about it before.
Awesome. Well, right before we dive into that, we have a few keys to give away this week. So Mother Gunship, which is a team, I think they're based in the Boston area, has just on Tuesday released Mother Gunship, which is a bullet hell roguelike first-person shooter game all in one, developed by Grip Digital and Terrible Posture Games. So it's available on PC, PS4, and Xbox One. So
And we have 5 Steam
we've
keys.
got some keys for you all on Steam. We'll be dropping those in. So first come, first served, I guess.
First grab, first,
Yeah,
something,
like
I don't know.
but thank you all for joining us, and
this is great.
feel free to dive in.
Okay, so Replication Graph. Let me first start and say this is a bit of a warning. This is kind of more advanced stuff, and if you're new to networking and replication, the stuff that Ryan is going to go through is going to be a lot kind of better for you to start with. This also doesn't, if you're learning networking, learning replicated properties and RPCs and how to write game systems in networking, that's kind of like the first thing you should be focusing on. This really is about server performance, and especially with games with lots of players, like 100 players, and high actor counts. Fortnite BR has about 40, 50,000 replicated actors in that map. So that's kind of the scale that we're at, and this is kind of like more advanced stuff. So just kind of keep that in mind as I go through. So to start off then, Replication Graph is a implementation of Replication Driver. And Replication Driver is a new thing in 420, which allows you to customize the replication logic within the network driver. Okay, the network driver is already subclassed based on sort of the socket level stuff, like IPNet driver, and various platforms will subclass that differently. So that's why we kind of have to go like a different vector there on in terms of customization. So replication driver is a new thing, and you can customize your replication logic with it. And so what does that actually mean? It mainly means customizing server replicate actor. Server replicate actor is kind of the sort of long time existing function that basically determines what actors should replicate to what connections. Okay, so what does that actually mean? That actually means opening actor channels, calling replicate actor on those actor channels, and then figuring out when to close those actor channels. That's really all this stuff is doing, is finding the most efficient way to give in 50,000 actors and 100 connections, how to figure out which of those combinations should do those kind of 3 operations. So that's kind of the part of the pipeline that we're really talking about. Once you decide to replicate an actor and you do property replication, and that's where we delta the properties, we figure out what's changed, we serialize, and we eventually write to packets and compress and do all these other things. That kind of happens at the end, and that's not kind of what we're talking about right here. This is kind of this limited, this kind of upfront phase of the pipeline that's kind of previously been hard to do these types of optimizations with. And so let me explain what I mean by that. So usually in Unreal, what you normally have is you have like these virtual functions on your actors. You have like isNet relevant and like getNet priority, and you have a bunch of like variables on the actor itself that you can change, and that'll determine like who replicates to who and how often they replicate. And that's a good model. It's kind of your classic like object-oriented like programming model, and that's like easy to understand and it's easy to work with, but it's very hard, if not impossible, to do these kind of like high-level optimizations for kind of what you need to do for a game like BR. And so, and what I mean by that is when every actor just has a virtual function that you have to call, and it's going to do whatever it wants to do. Like you have no idea what actor is going to, what they're going to do frame to frame. You can't really, you can't. You have to kind of call those functions all the time, because you can't rely on like when is the output going to change of it, when is the return value going to change. You don't know what that object's doing, and it's just a black box, right? So it's really hard to like to make these kind of optimizations, and basically the old system becomes slow when it's sort of when you scale on those 2 axes on connection count and actor count. You just have to, you're continually calling those functions and continually kind of like redoing work, because you have no insight. So RepGraph is kind of like the answer to all that by creating a more persistent data structure for connections and actors, such that you can quickly pull the data you want out of that and kind of get it on to the next phase of the pipeline. So yeah. So I guess. Let me just kind of give an example then, just real quick. I'm going to just bring up what the Fortnite replication graph looks like, and I'm not going to actually explain what the nodes do yet. We're going to kind of work up to that, but just kind of as an example. This is something I kind of, as we were making this, I kind of brought this up, or I sent this out to the team and stuff to kind of try to help explain it. But the idea here being, kind of the high level, you have like sort of the replication graph is kind of like the root node, and then it has like nodes within this graph. And these nodes in this graph, their job is ultimately to produce actor lists to replicate actors on, actor lists of actors to replicate for a given connection. So we say, hey, replication graph, here's this connection, give me actors that should replicate to it, and the replication graph will return a list of actor lists, okay? And so some of those lists can be, ultimately the system does not care how those lists are created. Those lists could be persistent lists that are just kind of like, yep, here's this list that I have, and I'm going to give it to you. It could be a list that is like kind of created out of nothing, or kind of on demand by, inspecting other state, other aspects of your game state. They could be persistent lists that the game code maintains, and you just pull it from the game code, right? It doesn't matter exactly how those nodes produce those lists. But they produce those lists, and I'm going to kind of talk about the way that the Fortnite ones do. But the point I'm trying to make there is that it doesn't have to be one specific way. So I guess I kind of lead into that. Like some simple examples of this would be like, probably the main one is like spatialization. Okay, so like Fortnite's a really big is a really big level, and it can. Most of those actors in that level are only relevant if you're nearby them, right? They're not global actors. We have a big set of global actors, and I'll kind of explain how we like deal with those later. But like the ones that are like sort of spatially only relevant to you based on like properties of spatialization, they have to go into the spatialization node, right? We have one node that like handles all the spatialized actors, and then that node itself doesn't actually produce the list. That node just kind of contains additional nodes beneath it that then produce those lists. And so that's kind of what this thing is on the graph. And hopefully they can see if I like kind of highlight with my mouse here, but like grid spatialization 2D kind of being like, that's like the 2D grid. And I'll explain exactly more like what the actual algorithm looks like. But the main point being it carves the map up into a 2D grid and then has a bunch of, each of those cells in the grid has its own node. And then there's actually nodes within that cell node that I'll explain later based on like whether they move, they don't move, or if they go dormant or they don't go dormant, and then even some stuff on like streaming levels. But that's kind of the idea, is that the spatialized actors will kind of go off in there. But you also have other actors that are not spatialized, like player states and game state, and we have a handful of other like kind of like manager type of actors in Fortnite that do different, distinct things that are sometimes relevant to everybody, or sometimes only relevant to certain people on if they're on a team, or sometimes they're only, for example, like the player controller is only relevant to people on a connection. So you have to have other nodes to deal with those types of classes, right? If you just try to spatialize everything, some things don't actually spatialize, or it doesn't make sense to spatialize them, and so you kind of have to have like all these different nodes to handle these kind of different cases. So let's see. So the main thing, there's a couple other advantages to doing this type of approach. So mainly, a lot of the work is able to be shared across connections and across frames. Like once you have this like these persistent data structures, you're able to, clients generally don't move very far, very fast. So like in subsequent frames, we end up not having to sort of do so much work. Like everything's kind of like, I'll explain that part a little bit later as we dive right in. I think what might make the most sense is to go into maybe go into some of the code and kind of step through that, and maybe explain just a little bit of how this stuff is kind of set up. Replication graph.h is kind of like probably the best place to start. There's a decent amount of comments that kind of explain like what the subclasses are intended to implement, and then just has, I don't know, you can kind of like browse the header and kind of just get a feel for the class. The main thing being like replication node is the base class for all nodes in the graph, and replication graph is the actual class of that the nodes actually will implement. So we'll jump around a little bit more, I guess. Basic replication graph is ships with the engine. It should be side by side, like in the same folder that replication graph is, and it's meant to be kind of like a minimal example of how you can stand a system like this up, and kind of like what's like the bare minimum to get it working. So that might be, if you're thinking of writing your own version, if you want to like implement your own version of replication graph for your game, this might be actually a good place to start. There's also examples in shooter game also ships with a slightly more complex example that's a little bit closer to what the Fortnite replication graph looks like. But I think what would make most sense right now is for me to step through basic replication graph and show you how it's set up. So, I mean, you can see here it's just a class that extends from replication graph, and it implements a couple functions right here that I'll explain, and it also maintains, like, these are basically the high-level nodes that the replication graph knows about and is kind of routing actors to. That's kind of one of the main jobs of the actual replication graph class, is to create these nodes, and then as actors register and unregister with the replication system, it has to tell those nodes about these actors, right? Now, of course, like you could write a node that just like does an actor iterator or finds actors however it wants and doesn't have to have them routed to them, but that's, and there might be use cases where that makes sense, but I think for the most part you're going to want to use kind of this routing structure.
We've had a couple of folks ask, you keep referring to nodes and things.
Yeah.
Are these things that are being exposed to individuals that are using Blueprint, or is it
No.
purely in C++?
This is purely C++. These nodes are purely like within the native C++ classes. It's not, none of this gets exposed to designers, and none of this gets exposed to the Blueprint system. I don't think, if you're making like a Blueprint only game, I probably wouldn't use Replication Graph, but you know, if you wanted to, I don't think there's any, let me back up. I would not really support trying to like implement a replication graph in blueprints, but you probably could have a game that's mostly made up of blueprints where all your game logic is blueprints, but you probably could set up a replication graph in native, or you possibly could even use something like basic replication graph and get basic functionality in your blueprint only game. So yeah, hope that clarifies. So basic replication graph it really only does three things. It supports spatialized actors, it supports always relevant for everybody actors, which is kind of like be always relevant, and it supports be only relevant to owner actors, which is like the player controller or an actor that would only replicate to a single actor. So the first thing it does, okay, I think I probably need to, sorry, there's a lot of like setup here to like get to like what I actually want to explain. So please bear with me. This is just like the life of
the network
of a programmer, right? There's like, okay, so the important pieces of this are like what I've kind of been explaining up to now is like the actual graph itself, your collection of nodes and all that stuff. You also have the other data that's important is it keeps what I'm going to call associative data for classes and for actors. So it keeps, for every class that has unique replication settings, it will create a class replication info. So that should be, oh no, I don't know what that did. It should be in here. It should be, let's see, class. Yeah, so just as an example, so this keeps a little data structure that's associated with your class. And so like normally this would kind of be like in kind of the old system, this would be data that would just be on the actor itself. But this, and without getting too far into like the merits of like object-oriented programming versus data-oriented programming, that's not always the best. That's not always what you want. Like this data really doesn't change per instance of the actual actor. It's something that just is a property of the class itself. And so it does a lot of like things based on just what the actor is and not on properties that are actually on the actor itself. So whatever. My main point being is you have this F-class replication info that will kind of determine certain things about the actor. So this has like a scaling for distance, scaling for starvation, which is how long something's been that it hasn't been able to replicate, and distance and just the actual distance, the calling distance, which is like basically the equivalent of net call distance squared on actor. But then there's also like replication period frame and actor channel frame timeout, which that's a little bit different than it worked in the old system. Though, like actor channel frame timeout is how long we let the actor channel go before we close it. And so that can be changed. You can say never close it based on timeout. I'll close it myself, or you can change that however you want, depending on how often you're checking to see if your guy wants to replicate. The main point being is that you have class. You have some associative data that's specific to each replicated actor class. You also have associative data that is global to every actor instance. So if I go in here and search for replication info, I think it'll be here. Yeah, global replication. So global replication actor info. So this is kind of like data about an actor instance that is not connection specific. It means it's global to everybody. And so this is like the last time we called pre-replication, the last time the game code called force-net update on it, what its cached world location is. So that this kind of leads into another. Why is this system faster? Like if you look at the old system, it would. If you like put a break, if you started at the top of server replicate actor and put a breakpoint inside like get actor location, like we would be calling get actor location like just an insane amount of times on the same actor, even though we're like within a frame. We're in a window here where it's not actually changing, right? So you end up doing a lot of work a bunch of times, right? And get actor location, even though it's like as fast as it can be, it still has to check if it's attached to something. It still has to find the root component. It has to get the transform off that. It has to, it does all this work just so redundantly. And so kind of with this approach is like, hey, this is the actor's world location, and this is the vector that everything uses that has to do anything with this actor's world location, and it's one central place. It's in this one little compact structure of data that should hopefully fit on one cache line. That should be, just more efficient, basically. As dependent actor lists, and it also actually mirrors the class replication info settings, so you are able to actually change it. Actually, so some of the stuff I said, that wasn't totally accurate. I guess what I did say is that you are able to override some of the class replication info settings on the actual actor instances themselves. But we'll get into that later. I kind of want to, let me just kind of cover the basis here. So you have class info, you have global info, and you have per connection info. That's kind of the last main thing. So let me just search for replication. It's hard to see. So you have connection replication info. So this is the other. So the other main thing is that every actor, for every connection that it actually replicates to, will have a connection-specific piece of data associated with it. And this is kind of still the same thing of like, when's the last time it replicated on for this connection? When should it close? What frame should it time out at? Is it dormant on this connection? All sorts of stuff like that. Yeah. Okay. So we don't need to get too deep into all the settings on this stuff. But the main point being is, again, we have our big replication graph with a bunch of nodes that's going to produce replication lists. Then we have associative data for the class, for the actor instances at a global level, and then in the actor instances for every single connection. Okay, that's kind of like all the data you have to work with. And when you are writing your replication graph code, that's kind of how you should be thinking. You're either going to modify the graph, or you're going to modify that data that I just talked about, and that data isn't going to change the way that the replication graph system decides to replicate actors to you or not, to connections or not. So, okay, I think we can finally wind back again to basic replication graph and get back to what the heck are we doing here? So the first thing, basic replication, there's this function called init global actor class settings, which that's kind of the idea there is that you're supposed to populate that class, that class associative data here. And so the way, and there's probably a lot of ways you could do this, and I kind of even suspect maybe in future projects we would do something like replication profiles or some kind of like presets or templates or something like that, so that you maybe aren't even doing it quite at the class level like this. The way that this is working is it's actually just doing an object iterator over all the U classes, kind of throwing out the ones that are not replicated or that we don't really, or basically the ones that don't actually change from their. No, sorry, this one actually doesn't do that. The Fortnite one does. Sorry, so never mind about that. The main point being is that we iterate through all U classes, and the ones that are actually relevant to replication, which is right here, what we do is we're going to calculate. Basically, what I'm doing here is looking at the legacy settings that used to be on the on the actual actor instance themselves, and I'm building this F-class replication info, and then storing it off. So this, I mean, it's literally what this is doing is it's looking at the net, the server's max tick rate and the net update frequency, which is, a frequency times per second, and it's figuring out how many actual replication frames should be in between each replication call. That's the other thing about replication graph. It's like frame based, and it kind of assumes that you're going to run your servers at a fixed tick rate, or at maybe it could be variable to some degree, but it's most of the things, like most of the timing based stuff is not going to be floating point based on time. It's just going to be like a frame thing. Like this thing replicates every 3 frames, and we're expecting 20 frames or 30 frames of replication a second. I think there's a lot of advantages to doing that, but we don't need to get into that so far right now. So basically the point of that, what this is doing here is it builds up all this F-class replication info, and it stores it in this global actor or sorry, it calls set class info on the global actor replication info map, which then gets used by other things in other places. That's really all this thing has to do right now. It just has to populate up that list so that when we go to actually replicate an actor, we say, what class are you? And then, oh, you're this class, here's the data with this class. And we use that data then to initialize the global actor info, and then we will use that to initialize the per connection actor info when it's necessary. So the next big function is init global graph nodes. This thing it pre-allocates some lists. I won't super talk about that right now. But the main thing that I wanted to talk about is it instantiates the actual nodes themselves. So this creates a spatialization node. It sets the cell size. The cell size can be however big or small you want. I'll kind of try. I have a thing to show in a little bit about how the spatialization actually works. But this kind of sets up a very generic one that's basically really big and a pretty decent size as default. And you might want to tweak it to begin with. But really, it's real simple. You just call create node, and then you have to call add global graph node to actually add it into the global nodes. And then the always relevant nodes, which is stuff that's relevant to everybody, just gets created here. And this node here is just going to be an actor list that's like, if you tell me what the always relevant actors are, and I'll return them when asked. So there's not a whole lot going on to that node. And then there's the other function. The next function is init connection graph nodes, which so I don't know if I mentioned this already, but so nodes on the graph, like conceptually, you think of a lot of them as being global nodes, but a node can also be associated only with one connection or with a subset of connections. So you can have a node that's only this one connection has, or you could have a node that only a couple connections share. So like for example, team-based relevancy, like in like a game like Paragon or something, where certain actors are always relevant to their teammates. There might be a team-based like relevancy node, and that all people on the same team would share, right? So init connection graph nodes is kind of meant to like, hey, there's a new connection, and would you like to create a graph node for it? And this is how you do it, which is, again, you call create node, and then you call add connection graph node to actually associate it. And all this is doing is adding it to a list so that when that connection gets replicated, we make sure we ask that node what stuff it wants. So these three functions set the graph up and create the nodes and all that other stuff. The next two functions, route add network actor to nodes and route remove actor to nodes. This actually deals with routing the actor to actually populating the graph as actors come and go. And so you can see the function by the function signature. It gives you the global actor replication info, and we look at that and say, actually, I take that back. Let me see.
That is kind of hard to see, isn't it?
Yeah, no, okay, so the way the basic replication graph works, this is actually kind of even a little simpler, is, okay, that's right, sorry, I haven't looked at this one in a little bit. Okay, so the way basic replication graph works is it just looks at like the existing properties on the actual actor instance itself. It just looks at be always relevant and says, if you're always relevant, then I'm going to route you to the always relevant node. If you're only relevant to the owner, I'm going to route you to the actors without, well, I'll explain this in a second, but basically it's going to route you to the you're only relevant to this to your owner node, and then otherwise it's going to add you to the spatialization node, and it calls this function, which I can't quite explain why it calls this one and not the other ones yet. We'll kind of have to work our way into that, but the main point is that these routing functions are like high level actors registered or unregistered. You got to add it or remove it from the graph node yourself, and that's actually kind of, I think, always relevant node for connection. Okay, so I guess I can explain the way that the always relevant for connection node works in basic replication graph. The problem here is that you know that this actor only wants to be relevant to its owner, but it might not have the owner yet, right? When it's actually spawned, you may not actually have assigned it its owner yet, and I tried to build this to just be a little bit resilient to that. So you kind of, when you get registered, you don't actually go directly to the node, you go to this list for actors that don't have a net connection with them yet. And then in our version of server replicate actors here, before we call the main replication graph version, we're going to go through that list and try to see if these guys have owners. And if they have owners, then we will get them we'll call get always relevant node for that connection and say, and then pass it off to him. And now he's like kind of, his routing is now officially done. So that's, hopefully that part makes sense. But it's, like I say, in the end, we're just trying to get the nodes to the right, we're just trying to get the actors to the right nodes. And then once they're in there, they'll be pulled out during the real server replicate actors, and then replicate actor, the actor channels will be created, replicate actor will be called, and the channels will be closed when necessary. Wow, I've been talking for a while.
There's a lot to share.
Yeah, so, okay, let's see. Let me talk about the spatialization stuff real quick. Like like again, first off, the spatialization, the way the spatialization works right now is a grid. It's just like a grid system. It's actually really simple. We actually had an octree implementation at one point, and there were kind of actually some downsides to that. And maybe I can get to them in a little bit. But the main point is like, so it's just basically a grid. So let me just explain how it works. I got an image here. Okay, it's my awesome paint art. So, okay, so this is your map, right? Yeah. So this is your world, right? And you have a chest right in the middle, not to scale. We carve the map up in a grid just like this. The thing I think people get maybe a little bit caught up on, or it's easy to misunderstand, is you might think that, oh, this means that if I'm in the grid, the cell that the chest is in, then I get the chest, and if I'm not in there, then I don't get the chest. But that's absolutely not how it works. That would be really bad, right? Because you might have, the chest might be like right here at the corner of the grid, and you might be on this adjacent corner, and you wouldn't get it, even though you're really close to it. Like, so right, that wouldn't make any sense. So the way it actually works is, even though the thing is spatially here, it's relevant to everything, hypothetically, in this blue circle, right? So any forget the grid for a second, any player that's within this blue circle needs to know about this chest, okay? So the way it works is we look at, well, what cells are that? What cells are within that circle? And then the chest puts itself in, it's routed to the grid, to the spatialization node, but then the spatialization node puts it in multiple cell nodes beneath it, right? Mm-hmm. So kind of like this. So the stars here kind of represent the cell nodes that the chest, that will have the chest in them, right? So if you imagine this kind of like, you know, with more examples, with more chests and players and trees and buildings and all that other stuff, you end up with a bunch of stuff in a bunch of actors in these cells. What eventually ends up kind of creating is almost like little just mini worlds of replication. And so you can think about it as like, hey, you're in this cell, here is like the maximum, here is a pretty small list of actors that you might need to replicate, and it's not going to have any junk in it that you definitely don't. Now there's still distance culling that has to happen, right? Now if you look at like the bottom left here, like if you were, you know, you're really only supposed to get the chest if you're like in this top right corner here, but if you're down here, you shouldn't get the chest, right? And that still will be the case. Just because you are returned from the rep graph doesn't mean you're going to replicate for sure. There's still a phase where we have to still do a distance check to see how far you actually are, because we still have to prioritize the list that gets returned from rep graph. So the polling phase out of rep graph does not actually prioritize it. We just take all the lists that are returned, and then we have to prioritize and sort them, and then we go to replicate them. So when we're prioritizing and sorting them, there is still an additional culling step that can happen where we say, oh, actually you're not actually close enough to me yet. I'm not gonna worry about you. Yeah.
So if you're doing, they're kind of asking about the distance check. So
okay.
Why are you doing both? So you have all this replication graph, like you have everything stored in these nodes, and you're also doing a distance check. Why not just do a distance check like on the chest or something?
You want to, like, you got to think, like, there's 50,000 of these actors, and so you want to do like the vast majority of actors are not relevant to a given connection, and so you just want to do like the absolute least amount of work possible. Just looking at that actor and saying, where are you and how far are you from this guy, and then throwing you out and doing that like every single frame. Like just like imagine like at a given spot in Fortnite, like there's going to be like, you know, 45,000 actors that are just completely not anywhere near you, and you're going to 45,000 times 100 connections. Like that's just it does add up. Like that's why that stuff does not scale. So you kind of do have to do both. You get the kind of the broad face culling where you just here's like it's 1% of the, not maybe a little bit more than one, but say it's like 5% of all the replicated actors. You're getting a much smaller subset of that. Then you still blaze through it, and you still have to do the next step.
So this is much more performant than if you were doing a distance check. You're like just putting this bucket. These are the ones I need a distance check on instead of everything, and then moving on from there.
Yeah, so it's kind of like a broad phase culling, and then a narrow phase kind of culling. Like kind of, that's kind of how like physics engines and stuff work like that. Like that, it makes sense. Okay, so that's how spatialization works. And so I think I kind of roughly explained how basic replication graph works. I could go to, I'm thinking just based on time, I'm not, so shooter game rep graph, I'm going to pull it up here and just kind of this ships with the engine. You should be able to get this in 420, and this is much closer to what the Fortnite one is. But also, I have the Fortnite version here. I could maybe pull that one up too. Because I do kind of want to just run Fortnite real quick. Let's see. So one of the main differences is the rules in Fortnite got a little bit more complex than what would have worked in basic replication graph. And so I had to do this explicit node mapping thing where we kind of like, as we go to these functions that, we kind of saw with the basic one, like a init global actor class settings and such. It kind of does the same thing where it's iterating through all the classes and building that class replication info, but it also has kind of this stuff up here where I kind of have to explicitly say some of these guys have to be routed a certain way, or they're not routed because they're implicitly routed. That's actually a good point here. So like one example, like in Fortnite, for example, like you have, so the basic replication graph, how I was kind of talking how like if you're only relevant to a certain person, like I would just put you on a list until you got that owner, and then you would get routed to his node eventually once you got the owner. That wouldn't quite work with Fortnite. And it was actually maybe it could have worked, but it seemed a little bit. It made more sense to me to do it this way, where our per connection. Are always relevant for connection node. What it ends up doing, a lot of the actors that are always relevant to a given connection, you don't actually need to like maintain a persistent list. Well, it's good to maintain a persistent list, but it's not necessarily, you can usually like come up with that list just by knowing what connection it is. Like once you have the player controller, just as an example, once you have the player controller, you can get the pawn, and then from the pawn you can get like if it has a weapon or its inventory system, or all these other kind of dependent actors that are only relevant to him. So rather than like putting those actors through the same like machinery, you just can kind of like pull them out as we replicate. So let's see if I can find that. So here's like the gather. Here's the gather function for the always relevant for connection node in Fortnite. We get the player controller based off of like the net viewer. That's always the player controller. And we do some throttling here. I'll explain the throttling stuff a little bit later. But you can see here, like we grab like the Fort inventory. We get the pawn, and we add the Fort inventory directly to the replication list. Same with the pawn. And his current weapon, and then there was also some stuff. Oh, like this is like the view targets. I think this was like for like guided missiles or something else. If you're like I don't quite remember. And there's more stuff for streaming actors. We haven't even talked about streaming levels yet. Oh God. Okay. Let's see.
It's a lot to cover, man.
It is a lot to cover. So, okay, the other thing maybe about this, trying to think what are the good bits about Fortnite that I want to like just kind of make it clear that yes, we're doing this, and you probably need to do this in a big game. Okay, so the other thing is like the decision I made was to like not spread replication graph stuff throughout the Fortnite game code. And instead, the Fortnite game code just, when it has to tell rep graph stuff, it just, let me back up again. I think one point I haven't made yet is that replication graph, some of the things that we are giving up are, I was kind of railing a little bit on the virtual functions early, and maybe didn't make it totally clear that like replication graph does not call those virtual functions at all. Like isn't that relevant is basically not used at all in replication graph. And so because you don't have these virtual functions that the actors can implement, and you have this more rigid system, there's still things that change throughout the game that then change, that have to change that stuff in replication graph. Either it's the node and where the actor is in the nodes, or it has to change some of those settings that I was talking about, that associative data that I was talking about. And so to do that, usually what it will do is, what I'll do is I have the game code invoke these events that say, hey, something changed. So just as an example, like vehicles. Like when you get in a vehicle, you call this on vehicle change delegate, and anyone that wants to listen to this vehicle change event can listen to it. So replication graph listens to that, and when replication graph finds out that you've changed vehicles, it will put that new vehicle in. It'll do what it needs to do, which in this case it actually is. The vehicle goes onto the dependent actor lists for that actor, and I haven't explained what dependent actor lists are yet either. So a dependent actor list is also kind of a new concept in replication graph, which just basically, it's actually pretty simple. It just means, hey, this actor does not replicate on its own. It only replicates if another actor, if its owning actor replicates. So like the weapons are like the great example, or the vehicles, where we're not going to spatialize the weapons individually. Like there's no point in doing that. They're relevant if the pawn is relevant. That's all you need to care about. And the old system had that like only relevant to, I think there was an option in the old system to only use the owner's relevancy, but it's still it's still a bit different in the sense that like the weapon doesn't even get added into the graph, and it doesn't go through all this like machinery. It just kind of pops out at the end where it just says, hey, this pawn's going to replicate, and oh look, it has some dependent actors, and they're going to replicate too right behind it all the time. It also is nice because that guarantees the order of replication. Almost guaranteed. I shouldn't 100%. It's not 100% because they could potentially be split over packets, and that first packet could be dropped. So that's something I want to address at some point. But the main point is, for the most part, the pawn will always replicate before like the weapons or its other dependent actors. So yeah, Fortnite game code has to like tell replication graph a lot of times when things change. Like if dependent actor list is the best example, but I think there's probably some other examples of like us changing. For example, cold distance will change. I think there's certain like state changes that can happen where like the cold distance will have to change on certain actors. And even for example, like during the lobby phase of Fortnite, some of those replication like settings and frequencies and stuff, we kind of modify them a little bit because there's so many people so close together that that performs pretty badly. So it kind of that stuff gets like really throttled down in the lobby, but then when the game starts, we like reset it. So that's like the game mode does that when it changes those phases, and it's all sort of that sort of stuff.
And to be clear, a lot of the benefit of doing that model, kind of having the game code push these setting changes into the replication system, is that in contrast to the legacy replication system, where that system was kind of polling for these settings every frame or multiple times a frame if it had to replicate, the same actor to multiple connections. Sometimes it was, pulling that data through possibly one of the virtual functions that Dave mentioned, and that's, like you said before, it's harder to kind of control the performance of that. And a lot of these settings don't change frequently enough where we actually needed to do that. So this was a big efficiency win for those reasons.
Yeah, I personally like that it's all kind of here, like all the real nitty gritty of like replication at this level. Like obviously replicated properties and RPCs and how the game code net replicates is in those classes, but this sort of like how fast is the server going to be able to replicate everything is kind of like all controlled here, so you get this nice holistic view. Let's see here. Oh my gosh. I wanted to talk just a little, I guess, the other big points about the Fort replication graph that I haven't covered yet. So let's go here. So grid cell here is actually a bit more complicated than just a list of actors that are within the grid. We still subdivide them based on whether they don't move, they're static, they never move, And so we never have to update their position, basically, frame to frame, if they're always moving or usually moving, like pawns and bullets and vehicles and that sort of stuff. And those actors, we are continuously, once per frame, per actor, we're figuring out if it's changed cells. And even that alone is a huge win, right? It's way easier to go through all your dynamic actors and see, are they still in the same cell, doing that one time rather than doing stuff that's per connection and per actor, whatever wasn't, yeah. And then there's still like dormant actors where, for example, a weapon pickup, which when it spawns, it actually can move, it can fall, and it can roll down a hill, and that sort of thing. But once it settles, it's basically nothing else is going to move it. So it kind of goes back and forth between being able to move and not being able to move at all. I mean, in some ways, like the pawns kind of stand still, but they could start moving at any time, and so you wouldn't really want to like take them on and off that static versus dynamic list, because they really are always could potentially move, but once like the pickup stops moving, it's going to always stop moving. And so that's kind of what I mean here by dormancy controls whether it's static or dynamic, is kind of what it means at that level. This is all in grid cell 2D node, or grid cell 2D node, I think. And so then, okay, the other thing we've been glossing over here is the streaming levels. So streaming levels that was actually another big pain point in the old system. Okay, so first, the way that streaming levels and replication work are usually, historically, that's how it's kind of always been, is the clients tell the server, I've loaded this level, and they tell them, and they tell the server when they've unloaded the level. The server doesn't, I think the server can issue explicit, you should load this level now, or you should unload it commands, but that's not how Fortnite works. The way Fortnite works is just, we basically have these actors in the map, and as you get close to them or far away from them, we stream them in, or we stream things out. And although the server could kind of guess and be like, I think he's here, and so I think these are the levels he has loaded or he doesn't have loaded, all the different platforms we support and different like hardware and hard drive speeds and that sort of thing, like you can't really rely on, the server shouldn't really rely on what levels the client has loaded at any given point. It's better for him to just tell the clients to just tell you. So whatever. Backing up, actors that are within streaming levels, we don't want to replicate stuff to a client if he doesn't have the level loaded. The code is resilient to that because of like networky race conditions and things being in flight when levels are loaded or unloaded. So the system can handle that, but it's inefficient to like replicate stuff and have it just be like, I'm not going to do it because I don't have the level that this thing is in yet. So we do additional stuff on streaming levels. And the old system was slow because to handle this, it would, every actor for every connection, before you did anything, you had to say, what level is this actor in? And then you'd have to say, well, here are the levels that this guy has loaded, and does he have that level loaded right now? And that's actually kind of a lot of work. There's like 30 plus, maybe 40 or 50 even streaming levels in Fortnite. So that would be a list, or I think we moved it to a T-map or a T-set at some point. But it's still like it's just all this bookkeeping that's just very redundant and doesn't really often change. So that actually was one of the hot spots in the old system, especially when we went to the streaming levels. And so the replication graph, kind of like the nodes that are at least are shipping here with 420, they give you some options for how to do this in a better way. And so basically the way that it does work is, rather than keeping one big list of a bunch of actors that may or may not be in streaming levels or different streaming levels, we won't at these kind of leaf nodes in the graph. It further gets subdivided and said, okay, these are the actors that are not in, these are the dynamic actors that are just in the persistent level, and then here's a list for all the actors that are in this streaming level, and here's one here is a list for all the actors in another streaming level. And then when you go to pull the actor rep list for those connections, for a connection, you say, you basically do the culling or the filtering out at that level, where you just say, do you have this level loaded? If you do, if you don't even give him this list. Don't even give him any of these actors, because he doesn't need to know about any of them. So the culling basically just happens like ideally one time and as early as possible, and so you have the least amount of wasted work. So I think I can show you just like real quick what that kind of looks like. So one of the real basic, well, it is this guy right here, but let me show you let me back up. So replication graph node actor list is kind of like your sort of basic leaf node. It's a node in the graph that just contains conceptually what I just described, where it's actually not just one replication list. It's it's one replication list for the non-streaming level actors, and then it's a collection of actor lists that the streaming level actors will go in. And so I think originally I kind of was only using, I just decided to build, I think it makes sense to have this node handle the streaming case and the non-streaming case. Even if your game doesn't have streaming levels, like the overhead of like having this extra thing here is like nothing. So the main point being, this is kind of all, this streaming level business is kind of all encapsulated into this guy. And specifically, it's actually this structure here, this F streaming actor level collection, this F streaming level actor list collection, which does all that stuff I just described, where you kind of call, you have add actor that will see if he has a streaming level. Oh no, this actually sees if it has let's see here. This is just finding what list this actor should go in based on his streaming level. If you passed if you passed an actor into here that didn't have a streaming level, it would just go in the none streaming level list. And same with the remove and the reset. And there's basically, so yeah, here the gather. This is kind of the thing of the gather. This is what I was just saying. So when you go to gather replication lists from for a given connection, these are the parameters that get passed in when you're gathering, when you're doing exactly that. This is the function that then just gets called. The parameters has this function called check client visibility for level, which that in the end just does, it just says, hey, it actually does this little optimization because it checks the last one that we checked, because that's usually what it is. But if it's not that, we go to, there's just a T set of F names that the actor has. These are the level names that the actor has loaded, and so that's just kind of the quickest check to do. So, okay, I think that's enough on the streaming level stuff. I think that that's pretty much the basic idea there.
That's the
And if you-
gist.
That's it? That's the summary?
Well, streaming levels, I had more to do.
I feel like we're going to have to turn this into a series.
Yeah, I don't know.
Seems like there's a lot to cover that we haven't even...
Scratch the surface here.
Yeah.
I think, okay. Can I show Fortnite real quick?
real quick,
Real quick. Let me just do.
because we're
Oh.
approaching our
Okay. Just
our time limit, unfortunately.
so. Okay, if you ever use this, here's what I suggest.
So if
like,
you're showing them, it'll need to...
oh yes, right. Okay, here's Fortnite. Hey, Fortnite's running Pi. The way I debugged a lot of this and did this stuff was like, there's some command. So wait, first off, gosh, sorry. Replication graph debugging is a header file, I think. Yeah, replication graph debugging.cpp. This has like a bunch of like useful stuff that you can use to like inspect the state of your replication graph and even change things on the fly and kind of like use this how you want. This one is probably the most. I think this is one of the best ones. Or actually, print graph, and then there's also I think like print all is the other one I was going to say. But let me just show you how those work really quick. So right now there's not much in the graph. It's just basically a player and then all the. If I do net.repgraph.print graph, it's going to log to the. You have to run this on the server, but this is Pi. Like the server is in the same instance, so it got the command. But you do a print graph, and it's going to basically just print out all your nodes. So here's the grid spatialization 2D node, and you can see that most of the cells, all the cells, only have the player pawn in them. The player pawn Athena is the name of the class in Fortnite. And there ends up being like 30 of them, 35 of them in this test map. But then you also get your. This is the always relevant for actor list. This is the always relevant list. So you have like the client announce manager, the special actor replication info, the POI manager, the global event ability actor, blah blah blah. We have a special node for player state frequency, for player states themselves, and we kind of round robin them where we replicate one player state per frame. I can't get into why we do that, but it kind of helped us because our player states are kind of big. And yeah, so the main thing I wanted just to show is that you can use this to figure out what your graph looks like, and then you can also use, if you do, what I'll do here is, let me build some stuff. Oh no, no, there it is. Okay, so I'm gonna build a couple walls, and then I'm gonna do. If I do net.repgraph. I do print all. I think with default parameters it'll print one frame, but you can tell it to print like 5 frames or 10 frames or 100 frames if you want to see like stuff transition and then you like looking through logs. So now you can see like in the grid cells you have within the dormancy within the dormant. Oh, I didn't even talk about why that. Okay, we can't get to that. Sorry. The main point is that you see the PBWAs, which are player-built walls. You see them pop up in the rep graph, and then at the bottom here, what you do is you see what was pulled from the rep graph for that connection. So that's like this part right here, and it says these were the guys up here that got culled out because they weren't ready to replicate yet. Not ready means they haven't, like the replication period frame hadn't been. We've replicated recently, and it's not time to replicate them yet. So they got culled. And then these are all the actors that we prioritized, and 8 of them passed, and this is how we prioritized them, and this is why we prioritized them, and then that's pretty much it. Anything that came in here, you can be assured that replicate actor got called on, and oh, actually that might not be the case. If you saturate the connection, they might actually get starved out. So. Let's not worry about that. The main point is
they tried to replicate.
They tried to replicate. So yeah. So the main point is like I don't know. So what I really did to optimize a lot of Fortnite was I just went into the map and I played and I kept running these commands and just looking at what stuff was in the graph and what was being pulled out, and I got it so that we pulled out the minimal stuff possible. And once the smaller that list got at the bottom there, the faster the game ran, and that's kind of like ultimately what I'd recommend doing if you have server performance needs. For replication.
So make the list smaller.
Make lists smaller is really what I should have just said
That's
at the beginning.
Just getting there is
That's the TLDR.
Yeah.
TLDR.
just all of the other code that takes to get there, and that's a lot of code, man. I think we got some questions. Do we have time for a question or two?
A few, if you're willing to take some questions.
I can do questions. Yeah.
So let's see. Where do we start? They're wondering, does the replication graph allow you to change the update frequency of an actor for a given connection?
Yes, yes, totally does. And you couldn't do that before, right? Now you totally can because it's on the per connection. Let's say the associated per connection data has a replication period frame on it, and so you can. That's literally what we do. We're like, we replicate your pawn every single frame, but like we'll throttle other pawns if they're far away from you. And as I say, like the game code basically indirectly does that by getting too far, but yeah, you totally can do that, and that's actually one of the nice things about the system.
Awesome. They're also wondering, can it be extended to like actor properties? So if they've determined an actor is relevant to a connection, can they then determine whether or not a property like animation state, attachments, etc. is relevant?
Yeah, we kind of started just doing that. I don't know if this made it out in 420 though, but if it's on GitHub, you can start looking at it and.
So if not now,
if not now, kind of in the future, and kind of what we have here is what it is right now. It's kind of called fast. Oh man, it's a little. It's a bit. Yes, you kind of can do that. Basically, what it lets you do is say, do I want to do the full replication path, or do I want to do a different replication path? And when I say different replication path, what that actually ends up really just being is an RPC, and that RPC can have a parameter, and that parameter can have the replicated properties that you want. The advantage of doing it though, is that whole thing, that whole packet that you make can then be shared between all connections, so you don't even have to like replicate every property or even check. You just say, here's the latest thing. But the downside there is that's not then tracked like the way other properties are replicated. So like there's kind of some weird edge cases there. So that's probably not really ready for prime time. But yeah, I think we're kind of working towards that. And I think it wouldn't be like on a perfect per property thing where you'd be like, I can replicate any arbitrary set of properties I want. It might be like, here's 2 or 3 like rep layouts, and you can choose which of those rep layouts are going to replicate to the actor, and that's like the set of properties within it. That might make a lot of sense at some point, but I don't know when we'll get. I don't know if I don't know when or if it'll actually get to that point. But it does make. I think conceptually it does make sense where you just want to like, you have like this a lot. You have some state that doesn't have to get there as frequently, but you have other state like movement transforms that you want it as quickly as possible, and that's definitely like a good goal, and we want to do that. And I think RepGraph will kind of help you there.
Awesome. They're wondering, have we added any replication mode for replicating to a spectator? And their example was, we'd like to look COND_owner and spec only.
So at the property level, I mean, there's custom.
There's nothing really built into the engine for that. I mean, ultimately, a spectator is just another entity in your game that needs replicated data. And now with the replication graph, it's probably easier to customize if your specific game wants to behave differently for spectators. Maybe they want a larger relevancy radius, for example, or things like that. A big part of the power that you get with the replication graph is that you can customize those properties per class, right? So if you have a separate, player controller for your spectators, for example, you can write logic in your subclass of replication graph that behaves differently when actors replicate to that specific spectator class, as one example.
If spectator XYZ do this kind of thing.
Yeah. So like even like Fortnite specifically does kind of, it's not at the property level, like I think like you kind of were asking, but like we do have if you're doing like a live spectator mode, which isn't really like, that's what we did with the Pro-Am thing a few weeks ago, or months ago, where someone's connected to the game. They never were a player. They're just spectating the whole time. Basically, like Ryan said, they're just a special connection, and we just give them a special node. And that special node has different, whatever. It has more actors in it than the other people normally do, and then we modify their per connection actor info stuff to like extend relevancy radiuses, or basically give them a special set of rules. And so yes, replication graph totally could help with stuff like that, but it doesn't really help you on the like, oh, I only want to replicate this property to a spectator, which isn't really, RepGraph won't help you there, I guess.
Right.
Gotcha.
Does this allow them to prevent multicast variables from briefly getting set beyond the range of the net call distance? Or is that
Okay.
fixed,
Oh, multicast.
unfortunately?
Do you mean multicast RPCs, not properties, probably?
Maybe.
Okay, so like that I didn't even talk about that, and I was real quick just say replication graph can also modify how RPCs get routed. So and specifically, that would really only make sense for multicast RPCs. So I think that's what you're thinking. So that's what you're asking. So here in this code right here, replication graph process remote function essentially hijacks that part of it, the routing of the RPC, and here's an example. So multicast. This is how we handle multicast RPCs in the rep graph. I don't think it's there's some extra stuff that kind of got added here that I can't quite get into, I think, with the time we have. But yes, if you want to customize when and under what conditions and who a multicast RPC goes to, you totally can do that with replication driver, not even replication graph. But yes, even within replication graph, you can change that however you want. You can have special rules and special relevancy checks and do whatever you want to determine who should get the RPC.
We've had a couple folks ask about streaming sockets, datagrams, or both. I don't know what this means, but
If you're asking about general networking, I don't think that really has much to do with replication graph.
Okay.
Replication graph still just sits on it uses the existing kind of UDP network protocol that Unreal Networking has always used for gameplay replication and networking.
so that's sort of a separate.
It's kind of a separate
discussion.
topic, yeah.
Okay.
But if this is what you're wondering, Unreal does use UDP datagrams for its gameplay networking.
They're wondering what is the potential though that the network, the replication graph could handle. So right now, obviously, Fortnite supports 100 players, but could we do 500 players or 1,000 players?
It's really hard to say because it still matters on.
It depends on what's in.
It depends it depends what your target frame rate is and what hardware you're running on and how many replicated properties you have. So there's like all these other different variables. But I mean, I would say, yeah, at some point, like if you try to do 1,000 players, like that's, at some point you probably got to either go multi-threaded or multi-server, and RepGraph might eventually be able to help you there, or at least Replication Driver potentially could. But I'd say kind of right now, as it's shipped in 420, like it's not, there is probably going to be some limit that you would hit that's somewhere above 100, probably less than 1,000.
All right.
You're hitting MMO levels at that point, though.
Yeah, but again, I think it depends too. If you just wanted 1,000 player, like say a 500 player deathmatch game where there isn't like destructible buildings and stuff and all that other, like if it's just like, you know, Unreal Tournament kind of thing, like you might be able to do it. I don't know. It really, you could try it.
Just try to get your list smaller.
Yeah, no, I mean, just
ultimately it, right?
That's it.
yeah.
That's the summary of this. So.
All right.
Yeah, and you have a lot of tools to help you with that too. Now that you can kind of customize all that replication behavior, you can more easily go in and tweak, you know, frequencies for individual classes, and just it opens up a whole lot more optimizations that were kind of opaque in the old system. So it's easier to tweak that for your specific game and your game's behavior.
Sweet.
Excellent. This has been very informative. There is clearly a lot
Yeah.
to this, and I feel like we've, as
Scratched
we
the
mentioned,
surface.
just
We've scratched, like we've gotten to the like underneath the surface and scratched like the subsurface. So there's a lot going on.
Oh, yeah. No,
So-
And we didn't even have time to cover the stuff
I
I was
know.
going to talk
No.
about.
Well, we appreciate you coming and hanging out with us, though, man. It's been great. Like,
Happy to.
sitting next to you has been fun. So,
Oh, well.
this has been super awesome, though. I
Yeah.
really appreciate all the info. Like, I know the community has just been, it's probably one of the most active chats
Yeah.
we've seen in a while.
Oh, cool.
So,
This is obviously very important things, especially for building your games, and as this is a new feature, having this information is valuable moving forward. Real quickly, I've dropped the link to our survey that we do after each chat, or after each stream. This lets us know what topics you'd like to see on the future, how we've done this week, and now we're giving folks the chance to win a t-shirt. So if you provide your email address, we'll enter you for a raffle that week to potentially win some Sweet Engine swag.
some sweet
And
news.
we'll send it out to you.
Yeah.
As always, check for your local UE4 meetups. There's cool folks all over the world working on Sweet Engine stuff, and this could be your chance to meet some of those people in person, get feedback on your game, do workshops, and various things. Each group's a little bit different, but check that out at meetup.com/pro/Unreal Engine. Also, submit your projects to the NVIDIA Edge program. I would love the opportunity to send you a GTX 1080 Ti, provided by our generous partners at NVIDIA. So tweet out at us, hit us up on Instagram, let us know what you're working on, and you could potentially receive one. Would you like to talk about the countdown?
I would love to talk about the countdown. So each week as we start the stream, we have a 5-minute countdown where we're highlighting projects done in Unreal Engine. So if you are working on something you'd like to see in the beginning of the stream, send us over a 5-minute version of a speed stream. So take an hour and compress it into 5 minutes. Include your logo and a short description of your game. Send that to community@unrealengine.com. We'll take a look at it, and if it fits within within what we're looking for, we'll definitely throw it up. Can't guarantee that it will, but please send them our way. And make sure you're following us on social media, Twitter, Facebook, Instagram, everywhere.
things.
All of the things. Twitch, make sure you hit the follow button here so you can know when we go live.
Yep.
Hopefully we can get you guys back to do another one of these and dive more into this stuff. And it's crazy. I'm in Discord and people are talking about this stuff. So I think this has been a great stream.
Cool.
So
Yes. Thank you
Thank
so
you guys
much
so much
for
for
joining
coming.
us this week, and we'll see you all next week. Bye.